Welcome to the Cortex Learning blog. This is tutorial 9 of 9, the last one, of input basics for CESAR 2. What we want to do here is to finish off our model that we started earlier and by applying an applied displacement at the final node. Up until now we've coded all of the lower section of the model, including from this anchor all the way through to the other anchor, reducers, T's, valves, etc. What we need to do now is to code from the intersection vertically up 7 meters, then horizontally in the negative Z direction by 2 meters, and then apply displacements to this end node. Those displacements will represent something like a vessel or a equipment movement, usually due to thermal growth. Okay, so let's commence by, as normal, creating a new element by clicking Continue. We want to move from 70 to actually 140. In this case, the default increment that CESAR 2 offers us isn't correct because we already have a node 80, so we'll make it 140. We'll now move in the vertical direction by 7 meters, 7,000 millimeters. This has now added that extra length, but we want to make sure, remembering our bend rules, we need to put a bend at node number 140. We want to make it a long radius, and we don't need single flange or double flange, it's just a standard bend. If we wanted to, we could adjust the location of the nodes that CESAR 2 inserts by default, but we don't want to do that at this stage. Let's move on to the final element now. CESAR 2 automatic increments are correct, so let's add an element of minus 2 meters in the Z direction. And the final thing we need to do is to put a anchor movement at node number 150. Now the thing not to do is to put a restraint there. The restraint doesn't allow movements, it's fixed. What we need to do is to apply a displacement. So double click displacements, make sure we've highlighted the correct node, and then select, and then notice that we have the ability to put in up to 9 displacement vectors. These are very similar to the temperature or the pressure cases, that the 9 cases that we have available there. So the first thing we notice is that the delta X expansion is 0, 12 millimeters in the Y direction, and 3 millimeters in the Z. The rotational displacements are all 0. Now we need to make sure that they go to 0 and don't leave them as blank. If we leave them as blank, then the system will be free to move in those directions. So let's see whether we can annotate this diagram to show where those displacements are, because the anchor doesn't show up as a normal anchor. So let's click the displacement icon, and notice that what happens is that the element that the displacement is on is turned red. If there are multiple displacements, then the multiple elements will turn the different color. We can use this technique to show, for example, temperatures as well. If we had multiple temperatures, this model would show up in multiple colors. We can do the same for pressures, corrosion allowances, wall thicknesses, insulation densities, and so on. So that's a very useful checking tool for when we come to error check our model. That's the conclusion of input, and in the next series we will be looking at how to create load cases and analyze the model.